back to my YouTube channel. So in this new topic, we are going to discuss about intermolecular forces. Okay, so in this intermolecular forces, we are going to discuss about what is intramolecular and what is intermolecular forces. Okay, so let's go to the properties of liquids and also solids. Okay, there are three important differences between gases, solids and also liquids. Okay, so here gases, they expand to fill their container. Second one, liquids, they retain the volume but not the shape, and for the solids, they retain volume and also shape. So for the first one, gases are easily compressed, but they can expand spontaneously to fill whatever container they are in. So here in this diagram, this is the gas where it is actually widely spaced molecule with much empty space between them. Okay, here, right, and the motion is random and with a very weak attraction between the molecules. While for the liquid, okay, these liquids retain their volume when we place into a container. For example, like you fill up water in a bottle, okay, but they conform to the shape of the container, and they are fluid and able to flow. Liquids are also nearly incompressible, and the molecules are tightly packed but with little odor, and they are also able to move past each other with a little difficulty, and the intermolecular attractive forces are relatively strong. And third one, we have solids. Okay, solids keep their shape and also volume and are virtually incompressible, and they often have crystalline shapes, and then other than that, what happened, the molecules are tightly packed and highly ordered, and very strong attractions between these molecules hold them in place, so they are effectively locked in position. So this is the diagram for gas. Okay, they can move randomly. Okay, and then while for the liquid, they follow the container, or they retain the volume and also the container. And then what about the molecules here? They are tightly packed, while for the solid, we have uniform, okay, order of the molecule. Alright, so and they have very strong attraction between molecules. Okay, so these properties can be understood in terms of how tightly the molecules are packed together and the strength, okay, of the intermolecular attractions between them. What is the main difference between the intramolecular forces and also intermolecular forces? Okay, for the first one, for the intramolecular forces, okay, the force actually which keeps the molecule together. Okay, so in this diagram, the intramolecular forces actually exist between this atom and also this atom, where it actually form a bond. Okay, alright, and then second one, intermolecular forces. Actually, this is attractive force between the molecules. Okay, right, and then it actually responsible for keeping matter in solid or liquid phase. So here in the diagram, you can see the intermolecular forces exist between these two molecules. Okay, right. So the intramolecular forces are always stronger than intermolecular forces. So here, this is a diagram of the hydrochloric acid. Okay, So molecules, okay, we have about 5 molecules of HCl. Okay, the interaction, okay, between this hydrogen and this chlorine here will form a bond that we call it as intramolecular attraction or intramolecular forces. And alright, the interaction or attraction between these molecule of HCl and also another molecule of HCl, okay, the attraction here we call it as intermolecular forces or weak intermolecular attractions. Okay, right. And then for the intramolecular attractions, they actually control the chemical properties, okay, of the hydrochloric acid, while for the intermolecular attraction or intermolecular forces, they actually control the physical properties of the substance, okay, of this hydrochloric acid. Okay, then for the intermolecular forces, they also generally much weaker than covalent and also ionic bonds. And so when they are weaker, so less energy is required to vaporize a liquid or melt a solid, because intermolecular forces control the physical properties of the substance. Okay, and the boiling points also can be used to reflect the strength of intermolecular forces. For example, we have higher boiling point, so the stronger the forces. Okay, so for the intermolecular forces, we have a few types, okay, in this topic that we will discuss. Okay, first one, we have London dispersion forces, we have dipole-dipole forces, we have ion dipole forces, and last but not least, hydrogen bonding. For intermolecular forces, we will be discussing about the London dispersion forces, dipole-dipole forces, ion dipole forces, and also hydrogen bonding. And for the chemical bondings, okay, this is what we have learned previously. We have learned about ionic and also covalent bond. So if we make a comparison between chemical bonding and also intermolecular forces, okay, you can see we have a large difference in terms of the energy. Okay, so we need a lot of energy in order to break the chemical bond compared to the intermolecular forces. Okay guys, that's all for the intermolecular and also intramolecular forces. So please don't forget to like, comment and subscribe to my YouTube channel. I'll see you guys in the next part. Bye!